Hello, everyone. Thank you for coming. I'm Julio. I've been working with cloud computing for more than 10 years now, 6 of them at Amazon. So that's most where my examples come from, but this should be very applicable to other cloud providers. I'm going to be as agnostic as possible and interactive as well. If you want to take any questions, no need to wait for the end. I would be happy to have a chat right away, right? And the goal of this talk is to help everyone be successful with cloud. And by far, the most common question I have and the most common problem I see when people are adopting cloud computing is the paradox of choice. And this is really nicely explained in a TED Talk by Barry Schwartz. I hope I can leave you with some good references, so take a look at that. And everyone here must have experienced that when you look at the hundreds of cloud services that are available right now in each provider. And this is a bit difficult to grasp. So I want to try to show you the main areas of innovation and how they're growing now, and try to compress this a little bit so it gets a bit easier to understand. So the four things I'm going to talk about today, these four areas of innovation, are those: application development, architecture, and something Amazon calls the well-architected, a bit of data analytics, what's going on there, and finally where everybody wants to get, and that's machine learning. And I have to go through this sequentially in this talk because we have linear and limited time, but this is not, of course, something linear in your organization. This is iterative development, so those things are mixed and intertwined together, right? So let's start with application development and what's going on right there. I really like this session from Lynn Langit a couple of years ago, where she shows a very important figure and a very important thing about changing in software development. You may think that architecturally or technically things are great, but unless you talk about money and time, these things hardly get through. So what is this trend about serverless? I believe you have heard this before. If not, serverless is just the ultimate goal of DevOps, let's say, where you can automate things to the limit, where you just write your own code and things get ran by computer somewhere, right? So the idea is that you develop your function, and that's what gets deployed instead of managing servers, operating systems, libraries, and things like that. And in this particular project, this particular example, a census program from 2016, so that was 3 years ago. The Lambda service from AWS, probably the first serverless thing we can talk about, is from 2014. So this is 5 years of serverless technology. So this is not new and quite well adopted and have this kind of benefit. And I'd like to show you that this is not new and not limited to these cases. This should be very familiar because do you know where this happened? Right here. So this case was the Australian census website that costed the government about 10 million, and 2 students made a replica at a hackathon with exactly the same requirements, but building with serverless technologies and letting Amazon do the hard work. And that's not to say that the government or any other organization was ineffective, but perhaps just not seeing those possibilities, right? It happens over and over again in companies all around the world. So let me take another example. iRobot, they make these home cleaning robots. You've probably seen them in the internet with a pet over it. They love it. And they're built all around the serverless architecture. The idea is that from the gateway that takes the requests to the IoT, the execution engine, message exchange, compute resources, all of that is not managed by iRobot as a company. That's managed by AWS, and they are not running server instances like T1 or T2 or the things that you see on EC2. Those are managed by AWS. The computation of this is managed by AWS. And what changes does it make to the business? Well, these numbers are from 2018, so this is a bit different certainly by now, but they run around 30 million vacuum cleaners in the world. And one particular thing that you have to think about is that when they sell you a cleaner, they don't charge a subscription fee. So all the compute power that it's going to use in its lifetime has to be embedded in the first price that you pay. So running 30 million of those worldwide, how much does it cost? How much people does it take? So it costs them around 50K to run and 2 IT people to support, right? So you can see this is very drastically changing the way that the costs in development time, and that's why it's such a popular thing today and such a strong trend. And we are seeing the frameworks and the development infrastructure getting better for that. As we get, we don't have yet any serverless standard or any compute standard to build upon, but we have frameworks that are going that way. So the serverless framework, for example, is a layer on top that you can write your applications and deploy them to any cloud provider or even run them yourself with a minimal code changes. And here is a bit of a important trade-off. Because do you want this multi-cloud thing, or do you want to take the best of your provider? That's quite a interesting choice to make. If you want only the compute and you say, I just want to run my thing, you can run anywhere. That's probably a good thing for you, but you can also say, hey, I want to go with AWS, and they will also have a framework for that, or Google, or Azure, or something like this. So at Amazon, the framework for applications is called the Amplifi Framework, and they have components to add all sorts of applications characteristics with Amplify, add name of the thing that you want to add, and boom, you can add serverless functions as APIs. You have both serverless and as in REST or GraphQL APIs or machine learning inference or chatbots or storage or internationalization, and everything AWS can do to go until the point where it gets to your code and your application logic that no one's can be better than you. So that's how the cloud is changing modern application development, how much this is impactful in terms of money, and why serverless is taking such a good space. So let's talk about the well-architected for a little bit for next. So at Amazon, we have a very good history in the company. And it starts in 2001, a little more than Amazon dates from 98. So this is about 10 years, 11 years after the company actually started. And it was a huge Perl library. They're built by a single team. And we already had categories, affiliates, and things like this. So you can imagine how hard it was to deploy this thing. So you have to integrate the code, check with everyone, with all the teams and professionals. And this was getting Amazon slower and slower and slower to develop. And Jeff Bezos himself, one of his ideas was this. He literally went to a weekend out to think about this. And when he got back in Monday, there was this rule. If you can't feed a team with 2 pizzas, it's too large. You need to break down the team in 2. 2 American pizzas can feed a lot of people, but it's going to be 12, 15. It's going to be a small number of people. And in this, and more, and this was, can you imagine how many managers got pissed off because their team got reduced by 3 times, and how many more managers had to be hired, and the whole organization restructuring that happens when this thing happened in the company. It was really traumatic by the time. And more because of this, we have this philosophy that you build it, you run it. So there is no DevOps team or security team or quality assurance team. If you're in an Amazon product team, you run it, you build it, you run it, you have to have DevOps, security, and everything that you need to run your service yourself. There is no excuse for downtime, security flaws, throwing code over the wall, nothing. It's totally self-contained and directly with the customer. So one of the developers in the team certainly carries a pager if something goes down. And well, that was 2001. What happened? 7 years after that, that's the end of possible visualizations of the dependencies at Amazon.com. This is our Death Star, and you can see how complex it is and how many duplicate things that's probably happened in there. And 11 years by now today, this is not even visualizable anymore. So it's, if you can't visualize it, imagine deploy it. So there's no way you can run things by hand. You have to adopt serious automation and DevOps and go serverless. Some of the new Amazon services are actually serverless because they use Lambda and there's other technologies behind, right? But even if you go with regular DevOps, that's what we had this day. So you will see all the benefits that you have. So one really strong trend is this automation to the limits of what's possible. So for some time, sometimes you can go serverless, and that's really easy. Sometimes you have to manage images and servers and be a bit more traditional in your architecture. But with automation and with DevOps, you can still get similar benefits. And with these automations over and over in time, you certainly improve a lot of your architecture, right? The idea of evolutionary architectures is very, very important for Amazon and for Amazon customers. One that gets cited a lot is Netflix. So let me show you a bit of Netflix under the hood. So this is the three regions that they run on in the US. So they run in 3 different regions. Each region has a set of availability zones. Each AZ gets its own data centers. So we are talking about hundreds of thousands of servers. Just so you get an idea, they run on the hundreds of thousands of servers with tens of thousands auto-scaling every day. So this each little ball that you're going to see here, it's tens of gigabytes of internet traffic. So let me show you the interesting part. At here, you see that when error rates are going up, and this is indicated by the red dots, they can automatically detect that. For example, it could have been a bug or anything else, shift traffic to the other regions, drain completely the region that's with a problem, fix the problem that they have, and then shift back the traffic to the fixed region. And all of that automatically without a single human intervention. So think that if an earthquake happens at US East 1, they get, or you can continue watching House of Cards because your request will be answered by the other locations that they have. So this is a pretty sophisticated level of automation, right? And you can have similar effects with serverless and Lambda and things like this. Let me get to. But that's a bit far off from where most automations I know stands these days. And how do you get there is the first question I'd like to tackle. And how to demonstrate it, because not everybody has a a video visualization of their network issues and things like this. So how do you, we all talk about evolutionary architectures that should evolve in time, but how to actually do it and how to demonstrate it to other people that this architecture actually have the capabilities that they have. So this is a pretty hard problem in architecture, and AWS has one suggestion for this, and it's called AWS Well Architected. And this is not at all particular to AWS. You can do this yourself, and I'm going to show you how. Because the Well Architected framework is based on the Amazon experience in building these systems with customers around the world and getting their information on what's important for security, what's important for performance, what's important for resilience, and things like this, and putting this in a structured framework. So when we talk about operations, it's not an affirmation, it's a question. So the framework is built by questions that you have to answer. So what's the value of the framework? It's having the questions themselves. What do I need to look for in my architecture? For example, in operations, how do you understand the health of your workload? Certainly, if it's serverless or not, it's going to be different, but you have to have an answer for this, or you should have an answer for this. For security, how do you detect and investigate security events? For reliability, how do you implement change, for example? In some cases, this may make a lot of sense. In some cases, not as much. So the most important thing about the well-architected program is being oriented towards the non-functional requirements that you have. So do customize this for your workload. If some question doesn't make sense, don't use it. If you need to add another one, whatever it is, just add it. But I think the brilliant thing about the AWS well-architected is this approach of going requirement by requirement in a structured approach that you can demonstrate how your software works. And this is available as a tool in the service itself. There is a well-architected service where you can fill this and track workloads and things like that. But I want you to get the idea. It could be your own well-architected, just the same, right? And why do you build well-architected systems? Well, I'd say one of the most fundamental things is getting data. Data is the new gold, right? We can do a lot once we reliably acquire data and don't lose it in any way, and can do a lot of cool data analytics with it. So let's talk a bit about modern application requirements and what I'm talking about when I'm talking about data analytics, because you cannot do or most organizations cannot do day plus one analytics anymore. So traditionally, when I started working, we had this database that was getting the transactions, and a database just like it, but the day before, so we can run reports and things like this. But consider Amazon.com with more than 2 million requests per second, or Snapchat with millions of active users, or the Samsung with petabytes of data and all of that. You just can't analyze this in real time and react in real time with the traditional approaches. And that's why we see the amount of new database and analytics servers that we have. So just at, you have that a bit varied in different cloud providers, but just at Amazon, you have relational databases such as Amazon Aurora, or MySQL or Postgres. You have key value for fast lookups with DynamoDB, document stores similar to compatible with MongoDB, for example, that you can store entire JSON documents, in-memory caches with Redis and Memcached on Elasticache, graph databases that are great for machine learning and tracking care of relationships, and even ledger databases if you're talking database component or blockchain or other trust relationship between parties. And keeping track of that is really hard, right? but it adds a lot of value. If you combine that with the automation that we were talking before, I would like to take a sample case of the value that it adds. So if you take a traditional, this is a study by a very interesting executive at GE called Marco Annunziata. He says that increase in efficiency of 1% in these traditional industries over the course of 15 years will generate around this amount of savings. And how does that happen? Well, I will let Marco tell you
So what is
himself.
this industrial internet?
Let me get to
Industrial machines are being equipped with a growing number of system optimization. Of course, electronic sensors have been around for some time, but something has changed. A sharp decline in the cost of sensors and, thanks to advances in cloud computing, a rapid decrease in the cost of storing and processing data. So we are moving to a world where the machines we work with are not just intelligent, they are brilliant. They are self-aware, they are predictive, reactive, and social.
So this is between machines. He's talking about both the growth of cloud computing and the growth of machines, and that's something I'd like to talk a bit more. And specifically in the GE case, where he's an executive, they work a lot with aviation. So just to tackle that example, every pair of engines in a modern aircraft generates a terabyte of information every day, a terabyte per flight. So that's pretty a lot, right? How to analyze that in real? What's that for? I mean, you can certainly think of a lot of use cases for this in analytics, but I'd like to highlight the case of predictive maintenance, because in an equipment like this, you cannot go back and say there is a defect. Would you choose to send the technicians, the expensive technicians, to repair this if there is not a defect, so it's a waste? Or if you go there and don't send the technicians and there actually is a defect and you have a disaster, right? So predictive maintenance is depending on this amount of data, right? And what impact this has for business. And this is the importance of the industrial internet, this marriage of data analytics and IoT.
How can the industrial internet help here? We've developed a preventive maintenance system which can be installed on any aircraft. It's self-learning and able to predict issues that a human operator would miss. The aircraft, while in flight, will communicate with technicians on the ground. By the time it lands, they will already know if anything needs to be serviced. Just in the US, a system like this can prevent over 60,000 delays and cancellations every year, helping 7 million passengers get to their destinations on time. Or take healthcare.
So that's the.
So how can
and this is not only on GE and not only on aviation. Ad roll on advertisement will have billions of impressions a day. Sonos and computer electronics with their sound systems, or Lyft or Nordstrom, they are all doing this kind of streaming analytics and using the elasticity of the cloud to process this at the scale that they come in and don't have to pay for the time where it's not coming in. For example, another great one is Major League Baseball, the League of Baseball in the US. When there is a game, it's about 7 petabytes of data per game, as far as I remember. But when there's no game, there is no cost, right? So that's the kind of advantage that the cloud builds and helps you get to the machine learning part, right? And that's where things get quite interesting. So at Amazon, we ourselves have the notification service on Amazon.com, the suggestion since the first days, since the very beginning. And what happens when you actually go there today? So today we have much more sophisticated recommendations based on video, based on characters and things like this. So if you take your personal favorite character from Star Wars and select it, you have the usual buying page for Amazon. And this is all things built by Amazon machine learning that are exampled here in their case, but those are all Amazon services that you could be using yourself to recommend things to your customers. There is a service called Amazon sorry. There are several Amazon machine learning services. One of them is SageMaker to generate this kind of recommendation. And a lot of services are built around this idea. And other forms of machine learning are very important as well. We have voice services for voice recognition. And the services for voice and audio recognition goes from generating audio to whatever kind of, it can go from your application, from your custom audio and video recognition up to ready-made devices like Amazon and the Echo. So that's the kind of innovation that we use a lot. And let's take a look what happens when you say, I want to buy something or I want to see this. You don't even need to buy it. If you just look enough times, perhaps your product is already going to be moving from one logistics center to another, where those tiny little robots will take the product that you selected, and you can see that they're organizing the shelves along with the recommendations. So if you see those things are bought together, those are organized together and taken together when you buy it. So someone goes there and actually, you see the amount of manual work and how compressed this shelves can be once they're arranged. And once everything is packed, things are shipped to the trucks using, again, very interesting pieces of equipment. But this is changing a lot, and we are seeing machine learning, of course, is driving a lot of that innovation, not only in packaging and logistics, but in all sorts of devices. This one is the first prime air delivery drone. So this is from 3 years ago, and it's totally real. This is not an Amazon employee. This is an Amazon customer living in Cambridge. That the fact the ordering process is the same, but the shipping is a bit different. When the box is packed, it's inserted in the drone and it flies off to the customer, right? And if this seems a bit futuristic, even being from 3 years ago, take a look at the Amazon Scout. This is the car that if you go to Seattle today, you can probably find one of those walking on the streets, and they will go to your doorstep and take. So it takes a lot of self-driving and machine learning and all those technologies we've been talking to actually handle this process, as you can see. But it is possible and it's doable, and all the services are there. It's just a matter of integration and building the app. This is the same services that are offered to everybody. So this is another example. If you don't actually want to go to the store, if you want to go to the store, we have the store in Seattle, the Amazon Go, where you can just pick your products and go. You don't even need to go through the cashier. You just enter with your app and take what you want and go. Image recognition, sensor on the shelves, all of this is there to support this kind of experience. And of course, that the limits of this are hard to imagine. And of course, this have good and bad implications, especially if you see the cutting edge of machine learning. I don't have a lot of time to explain all the things, but I'd like to leave one example of some interesting things that are going on. So take a look at this video.
We're entering an era in which our enemies can make it look like anyone is saying anything at any point in time, even if they would never say those things. So, for instance, they could have me say things like, I don't know, Killmonger was right, or Ben Carson is in the sunken place, or, how about this, simply, President Trump is a total and complete dipshit. Now, you see, I would never say these things, at least not in a public address, but someone else would. Someone like Jordan Peele. This is a dangerous time. Moving forward, we need to be more vigilant with what we trust from the internet. That's a time when we need to rely on trusted news sources. It may sound basic, but how we move forward in the age of information is going to be the difference between whether we survive or whether we become some kind of fucked up dystopia. Thank you.
So
stay woke.
So
we're entering an era.
So you can see that this is, with the current capabilities of machine learning and cloud computing, you can do very, very interesting things. You can sound like anyone you want in real time, like this video, and you can think of many more implications to modern days. For example, one that I think a lot is conflicts, armed conflicts, also known as wars, right? What happens, can you think of the kind of drone and arm and weapons that governments has these days, if Amazon already has this kind of drones in commercial use? And how does that apply to the other side that does not have this kind of technology and this kind of thing? So this is changing the world pretty drastically, right? I want to show you a few more things here. I don't know why this slide is not coming through. So when we think about cloud, what is cloud? And I hope I have shown you here in this talk that it's not about running somebody's, there's a nice sticker that says, there's no cloud, it's just somebody else's computer, right? And that's interesting because in a sense, yeah, it is. If you take a look at the hardware that the cloud uses, it's probably Intel, ARM, and most of the same hardware. The software, some part is proprietary, but a lot of it is open source, and even most of it. So what is the role of the cloud, really? It's innovation partner. So when you're picking a cloud provider, it's not only where you're going to run your code or run your serverless app, but who is going to, and how you're going to build the next things, right? And just to help illustrate that, I don't know why this is hidden. Just a second, sorry about that. Take the NASA Jet Propulsion Lab example. They sent the Curiosity to Mars, and the Curiosity is extremely based on the same characteristics that Marco Annunziata mentioned. Machines that are self-aware, that can operate predictively, that can predict what's coming and react to their environments, and especially be social. When the Curiosity was, both when it landed and when it was decommissioned, there was like worldwide movement, social media, and those things are every time more open science and things like that. Of course, you may not be interested in shipping a rover to Mars, but you may be interested in running a satellite. So Even school kids now can launch satellites. Low orbit and mid orbit satellites are being used by many applications, weather forecasting, geography, topology, a lot of science in this. And when you run satellites and space things in general, one of the things that are expensive is the device itself, the rover or the satellite. But another thing that is really hard is having the land capabilities to receive the signal. For example, you have to have a ground station to receive the data from the Curiosity or from the satellite. From the case of the Curiosity is a bit hard because there is about 1 hour per day that the planets are aligned sufficiently to talk. But when you talk about the satellites, they pass around the Earth, and when they pass on top of your ground station, they can ship data. So say they do it, let's say, for example, once a day, so you would get data once a day. If you have several ground stations, you would be able to get data multiple times a day. But building ground stations is probably not something that mid-school students could do, even though they can launch a satellite. So that's why, for example, there is a service now called AWS Ground Station, where you have ground station for satellites. So that's the whole idea of the cloud. It's not running servers or running computers. It's taking everything that's undifferentiated from your business and moving it to a provider. So the kids with the low orbit satellite, they just want to ship it and get the data. They don't care about ground stations. And their ground station is going to be exactly the same as the person next door. It's just a data center, so it would come just the same. So why not turn it into a service? So we have ground stations as a service now. And what do we get in this? And this then is not a product, a service, but this mentality that there is so much to be invented and so much to go on. This is day one, still in such a big way that it's great to have this ability to focus on our business and have someone to help with the things that won't differentiate you, right? And I can use the time to answer questions or show a bit more of this stuff in practice, but that's all for my content. Thank you. Any questions or anything you'd like to see? Let me try a few things. Someone? Yep. Let me show a bit of those in practice. Always use single sign-on, multi-factor authentication. And let's go to my AWS account so I can show you a bit of those things. So the first thing I talked about was modern applications with serverless. So why don't we get started with that, and I can show you how it works and what it is. So the most fundamental service here on AWS for that is Lambda. And again, I'm using AWS as a reference. You have Azure functions, you have Google functions, and you could do similar things elsewhere. And I'll create a function. I can alter from scratch, use an example, or there's a repository of existing apps if I want to see how to design and share an existing component that is possible. Let's pick one from scratch. I will call it my func NDC. You can pick your favorite runtime. It could be C#, Go, PowerShell, Python, and all other languages supported. Create the function. You can select permissions if you want to do a more fine-grained permission controls and things like this. But basically, I can put my own code here, hello from NDC, or upload it. And this will run on response. This code will run on response to the events that you set up. And you have all the triggers here. So API gateway would be an HTTP request. AWS IoT would be the click of a button. Alexa skills would be talking to an Alexa device, or CloudFront, or CloudWatch events, or in response to a commit. So you can trigger your function in reaction to several events. So you could say, hey, when someone commits code, do this. Or like a trigger, or on DynamoDB, or even MySQL, when a new row is added, validate with this logic. Or when an image is sent to S3, our storage service, generates the thumbnail. So your function can do anything you'd like. This is a very simple experience on the console, but we could use the same, we could do the same thing automatically in our IDE, in our CI/CD tools, and this would be, let me name it the simple event. Again, just to have some simulated data that would be passed to your functions as a parameter. And on the execution results, and I press test, it's executing the function, and here we can see that it returns my hello from NDC. It ran for 11 milliseconds, and I got billed for 100 milliseconds because that's the unit of billing, 100 milliseconds by 100 milliseconds. So that's where all that money comes from. So the idea is that if your service is running all night, if it had servers, I would pay for the service, for the server hours where it's running. Here, I'm only paying where the code is actually executed. So that's why it's so much cheaper, right? And I talk also about well-architected. And here in the well-architected tool, you can see all those workload definitions. I can define my workload and start answering those questions. Let me go with a simple description. And this is not a service in the sense that it will run something, or it will execute things, or it will just help you go through the machine through the well-architected questions. I'm not going to go through the questions right now. We don't have a lot of time. If you want to take a look at it, another way is the well-architected website. And let me show you where the information is. So if you want to take a look at all the questions and all the things about the well-architected framework, there is a link here at the start of the well-architected page to this PDF guide. And for example, let's take security. There are a few design principles behind that apply for all the questions. And here you have for identity management, detective controls, infrastructure protection, and so on and so forth. All the questions. How do you manage your credentials and authentication? How you control human access? And even sample answers in the appendix. So certainly there are going to be different services to help you with each of those questions. I highly recommend you take a look and understand your requirements. And don't be afraid of taking one out or adding an extra question if you'd like. I think that helps a lot in architectures. Then on data analytics, so let me give you one example of cool things we have in data analytics. I will show you one in DynamoDB and one in RDS. So in DynamoDB, when you create a table, and this is again a structured storage service where you can say, hey, I have a primary key called ID and a partition key time, for example, or I don't even need a partition key. What I really want to show you is the advanced settings here. Read-write capacity mode. And this is a clear example of how the technology behind serverless, and it's not only for compute. Here we can talk about serverless for databases. You have two modes for DynamoDB, the Amazon NoSQL database. You have read and write capacity that can be provisioned or on demand. When it's provisioned, you get to select how many read capacity units you want and how many write capacity units you want. So here you're saying, hey, I know I'm probably using this amount of reads per second and this amount of writes per second. There's a capacity calculator to help you define that. And I want to auto scale. When I reach 70% of my provisioning, I want to go up. And when I have, and the same for writes. You can define when you increase and when you decrease your limits. Or you can tell Amazon to go on demand and just say, hey, I don't care how many reads per second or writes per second I have. I just want to throw my data at you and I will get back this. It will answer your request, but it will be a bit more expensive than knowing your specific provision capacities. So that's one idea. Or for more traditional databases, there is still a lot of innovation going on. For example, I'll create an Aurora database. And that's a database engine that's built by Amazon. So it's Amazon proprietary. But on the protocol, it's compatible with MySQL or Postgres. So when you create an Aurora database, you get to select if you want it compatible with MySQL or compatible with Postgres. So you can develop and work as if it were MySQL or Postgres, but it will be faster, more reliable, more secure, with all the features that you can see here in the wizard. And let me highlight a few ones that are important. So, for example, you have the optional to have a regional or global database. So you can have the database in just a single AWS region or have it replicated with less than 1 second of latency to the other regions. That's only possible because AWS has a backbone interconnecting all the regions with sub-millisecond latency to make this kind of replication. And we have several patterns of database use. So if you have one writer and multiple readers, there is a configuration for that. If you need parallel queries, this helps processing queries by multiple reads by sending the queries to the storage nodes, similarly to what Hadoop and other data management systems do. But what I really want to show you is this idea of serverless databases. So when you run a serverless database, it's just like the serverless compute. You don't even have the servers at all. Amazon will take your query, run it against your data, and reply, and you only pay for that time. After that, you only pay for data storage. So that's, again, the same convenience and the same effectiveness in terms of costs that you have for the other servers. And things like, and the rest is pretty standard connectivity options. And finally, let me show a bit of the machine learning part. So we have here the machine learning services. And some of them are very easy to, most of them are very easy to use. For example, take Poly. Poly is speech synthesis. So with Poly, you can make it say anything you want. So if you have a voice application enabled, you can say, hey.
Hi, my name is Joanna. I will read any text you type here.
And you can see that it's a much more natural voice. You can pick from several and change the language and things like this. And even use speech synthesis markup to say how you want things to be said. You can spell numbers, whisper things. There is even a radio that uses this to replace some of the human programs that they air. Or with recognition. So if you're not doing voice, if you're doing images or video, for example, you want to take an image and see what's in it. You can see that in this image, it can recognize the person, the cars, the skateboard, and tell you the wheels, and tell you where it is in the picture. Or in this other sample, a skyline, and so on and so forth. And how this is in the, you can see in the side tab here. Let me get there. What you get back, the confidence in this, and this is just a very simple user interface for the very same API call. If you did that not on the web, but using your Python program or your favorite application language, this would be the result you get. So could you build a system, pick the OpenCV library, pick SciPy or your favorite machine learning and do this kind of things? Maybe, but how cool is it to get it done in 1 minute, just doing an API call and getting it back? For some cases, you may even do both. You may go with one while you build the other, or if you get a low confidence, do the other, right? And you can mix and match your machine learning with Amazon machine learning and humans in the process, and that's a very important part when you have machine learning models and training like this. And if you want, this is a ready model. Both Poly and recognition, we are talking about things that already exist. But we can use Amazon SageMaker to build our own models and do our own machine learning. So how does that work? I can create a notebook instance. That's the developer approach, my inst. I can pick the instance type, if I want elastic inference or not, a lot of configuration options. But I will create a new role. Roles are just Amazon's way of creating authorization policies. So I'm just saying that this notebook instance has access to S3, where it's probably fetching data. And it will create this notebook instance is actually a Jupyter notebook. And as soon as it's launched, let's see if it's already there. Not yet, still pending. It should just take a second. Any questions while that? Good. And you can see that this is a very much deeper machine learning platform with very interesting features while that goes on. Let me highlight this one that's very important. When you define machine learning, you have this thing called hyperparameters, which is just a fancy name for the parameters to your algorithm, not your data. So you're saying, like, if it's a tree-based algorithm, how deep the trees can go, how wide they should go, and things like that. And tuning that for models is a bit hard. So you have to create a network, for example, a neural network with 10 layers, with 11 layers, with 12 layers, and see how it performs, how accurate it is. So Amazon SageMaker can use machine learning to automatically tune your model to the parameter you want. You can say, hey, you can vary these parameters in this way and run it and give me the best configuration. And just that is probably saving many, many hours of machine learning development time. Let's see if our SageMaker instance is finally up. Not yet. So much better than this. Let me try SageMaker samples. There is a repo on GitHub with everything, basically. So Amazon provides, AWS Labs has this GitHub repo with all the machine learning algorithms and examples of all the tools and features of SageMaker. So, for example, if you want to do image recognition or text recognition or all the a linear learner, for example, is a very common example. So there is the Python notebook with all the things that are involved in creating a linear learner with fairness in SageMaker. And here's just a notebook, and that's the notebook that we will open when that instance runs, just a regular Jupyter notebook with the science, like the things you have to understand, a bit of the math, and the API of how to do it in code in SageMaker. And this, some models, this is a bit of a complicated one. There's the simple linear learner, but the whole idea is going through the steps, initializing SageMaker, get your data, and the notebook goes step by step on defining the data, training the model, and running inference. And that's the, you have the simple API where you create SageMaker session, SageMaker estimator, tell them what instance type do you want to run on, if you want it, how many of those instances you want, again, proportional to your data size and complexity, and just let SageMaker do the hard work of doing the fitting. And in the end of the notebook, you have the model. In the end, the output is an endpoint where you can just run inference. So that's how you would build your own recognition. So that's the idea of Amazon machine learning, making it all available to everyone. If you want the ready-made Amazon recognition that you can just ship the video or images and it tell you back the categories, perfect, go and use recognition. If you want to build your own model, let's say I want to recognize something very specific, like shoe brands. I want to take pictures of shoes and get details such as the thickness of the bottom, the brand, and whatever is my application handling. You could build it on Amazon SageMaker with the same algorithms or other supported algorithms in SageMaker, and they are all provided. And better yet, you can even customize the algorithms because on the backend, they're just Docker containers you can replace with your own. So that's all the time I had for today. I hope that was interesting for you guys. And if you want to get in touch, I'm Faerman J on most of social media. I'd be happy to continue the conversation with you. Thank you so much.